Today we have 11.3, day 2, okay? Day 2. And for those folks who are like, hey, what happened to day 1? That was yesterday's notes. It's in the video if you watched it. If you just did the PDF and you did 11.2 day 2, you missed out on the PDF on 11.3 day 1, okay? But the video had both of them. So we're looking at this today, and we are looking at just finding slant height of a pyramid. We are also going to do that in cones, and we will also be able to find the lateral area and surface area of both those shapes. Okay, those are today's notes. So I'm going to start out with problem 4 because it's more involved, but the stuff I'm going to do covers both of them. Perimeter is the number of sides times the length of each side. Okay, the number of sides times the length of each side, 6 times 36. Okay, 6 times 36. There are 6 sides here. Okay, 6 times 36 is 216 as I step through. Now, I should have this as feet, okay, if that's the answer I'm supposed to find, okay? Please be advised, today's notes is not just being able to discern where the numbers come from. It's you being able to recognize, and I guess it really comes down to this, shape, equation, identification. You look at a shape, and based on the shape of the figure we're working with, you pull out an equation that you can use, okay? Now, after you pull that equation out, you have to work to get items, pieces of information for that equation to work. And you have to know all the things about that. That's the study portion of this. So make sure you're getting it done. Finding slant height. Now, that's the next thing. If I'm going to find slant height, I got to know what it is. It's the lazy height. It's the height that's leaning against the figure as it goes up. The slant height here is the height that goes up the figure from the midpoint of the base all the way up to the vertex. Okay, that's slant height. It's the height of the triangle on that one face. So in this case, I've got a right triangle set up. And in order for me to use that to find slant height, I'm going to say, hey, L squared, that should be a squared someplace there, and L squared is equal to A squared plus B squared. Well, I've got A, my height, I'm going to use this 42, and I got B, 18 the square root of 3. My concern is you being able to take that 18 the square root of 3 and actually come up with the correct answer in there. So let's talk about that. If I've got 18 the square root of 3, as I put on my handy dandy glasses and work on a calculator that's on the TV, we got 18 second square root of 3 like this. Now, I have a lot of people that enter this in and think, oh, you know, this is cool, this is easy. And oh, by the way, that's a 42 squared, not a 12 squared. And because some people, where did it get 12? I'm going to go tap on that. You should have that into your calculator. 42 squared. You should be able to come up with 2,736. Now, I always have people think, oh, you know, it's a calculator. Anybody can use a calculator. I'm here to tell you, no, they can't. You need to practice using the equipment that you're going to actually perform on, okay? So, grab a calculator that you're going to use on a test, have it with you to do your assignments, to do your stuff, because practicing this, fat fingeritis, that's why I've come up with it when you push the wrong keys or when you're communicating with your calculator incorrectly. It's the #1 problem when people get everything right to the answer and it's wrong. And I mark off 1. I say calc issue. I'm not going to tell you what it is because it just depends. It's, you know, a parenthesis, it's this, it's that. It just depends on the person. Okay, what's going on? But know that this is an important thing, this calculator operation stuff. Now, I've got the square root of 2,736 in my calculator. I'm going to use that as L. That's my L. I just found it. My perimeter, hey, I found that too. It's up here. This is perimeter. It's down here. It's P. Okay, so I'm going to pop those two things into my calculator. So I'm going to take my 2,736 that I took the square root of right now, 0.5, times 108. And people are like, where did the 108 come from? It's 216 divided by 2 is 108. So I got 5,649. Hopefully that's what I have sitting right here. 5,649.13. Now, please be advised, I rounded it for this problem at this point. But the value of 5,649.13 3031 is still in my calculator, okay? Because I'm still working with that value. Now, I'm asked to find surface area. Surface area is my lateral area I just found, LA, plus my base. Now, here's the big deal. And every time we do this, students are like, well, what's B? No, it's not B. It's big B. Big B. Big B is a value that you find from the surface area of the base, the area of the base. And we've been working on area of the base. Base area is 1/2 ANS. Well, that was from chapter 5, Bloom. Yeah, chapter 5 is a prerequisite knowledge for chapter 11. So you have A, and then N and S is perimeter. N is S is 216. So I'm plugging in 1/2 18, the square root of 3, times 216, 16. Okay, so when I do this LA came from above, but then that stuff is right there. Check it out, weird, right? Let's try to redo that so you guys can see. It's the same deal, 1/2, 18 squared, 216. Nuts, that's crazy. Now, keep in mind, it's big B. You have a value of the area of the base. That's what big B is. If you're not sure how to calculate it, we got to talk because it's one of the basic things we got to bring in to chapter 11. Once we get big B and we know LA, hey, it's me plugging stuff into my calculator. I'm done. Okay, but if I don't know how to do big B and LA is a challenge, this entire chapter is going to be a challenge, and it's not supposed to. So make sure you're coming in, make sure you're talking, make sure you're asking questions. It's not a secret. If you don't work at something, you don't get better at it. Okay, I don't care what you're doing. Okay, and here's the biggest thing. Eventually, your mom and dad, your teachers, other people won't be there to tell you you're wrong or right. You have to make that decision, and you have to have the skills to recognize whether you're right or wrong. And those are all things that you're going to develop over time. Whether you're investing in the right thing for your retirement, whether you're making the right choice for your job, whether you're making the right purchase for your house, whether you're making the right improvement and picking the right company. It's all based on your thoroughness on what you do the research on. That's it. Nobody's there to say, way to go. Well, okay, maybe there are. There will be people saying, hey, way to go. You should come with us. It's the best decision ever. But they're the people you're paying money to. So those are going to say anything they can to get paid. But how do you know it is actually right? You got to go out and seek out other things. So remember that. This is a nothing thing. But if your numbers and my numbers are different, it's pretty obvious that we're wrong. Let's make sure we talk. But in life, you've got to make that decision. Okay, and you have to make it with information you collect. So we've got the first thing done. Sorry about my little soapbox, but that's where I'm at today. We got the second one over here. It's the same questions. I'm expecting the same pattern from you. Okay, so if I'm going to find the perimeter of the base, I first got to identify the base so it's easier to find the perimeter. Well, my base is a square, right? How would I find the perimeter if I know one length is 30? Ideas? Yeah, well, careful. That's area. If I square it, it's area. I just want perimeter. So if I started walking and I walked 30 meters, which is pretty long for me. I mean, without sitting down, that's something special, 30 meters. Okay. If I walk 30 meters and take a turn after, of course, my rest, and I walk another 30 meters and take a turn and do it again, how far will I have walked if I come around to the beginning? 30 times 4, right? So just keep in mind that's 120 as I'm doing it. Okay, you guys got slant height. Go ahead and find that. Sorry, here we go. We're trying to find slant height. Okay, and in order to do that, we gotta use height here. So I got my height coming down here. This is supposed to be 36.4. On your notes packet, it got cut off by the copy machine. So oops. So we gotta make that adjustment. The next thing is this point C. That's the middle of your figure. If it's halfway into your figure and the entire length of the side of a square is 30, how would you know the length of AC? What's half of 30? So we got 15. So half of 30 is 15. That's how I found it. It's the apothem. It's halfway through the figure. And now I've got two values to help me find L. So I've got this going on. It's squared, maybe, and I'm getting it done. Another square. I've got square issues today. Okay. Plugging this one in the calculators, not a problem. Everybody gets the same answer all the time. It's when we get those square rooted things that's really tough. But make sure you practice. Make sure you know. Okay. So I've got my slant height completed. Now that I have perimeter and I have slant height, I can quickly use those, because I plug them in, to find lateral area. Go ahead, get her done. How you doing? You plug them in right? Got them in my calculator? I'm getting it done? Thank you. Now, once I plug that in my calculator, I should come up with 2,362. Hund. Sorry, it took me forever to find the name on this. That's stuff for baseball. Okay. All right, so here's the thing. I've got LA. I found that from perimeter and slant height. My next thing, SA. Now remember, big B is the area of the base. Big B changes with the shape because the base change. If the base is the same, great, the base will stay the same. But most of the time when we're doing this, the base is changing. So I got to recall, hey, you know, this is the base of a square, and the area of a square is side squared. Well, that's just 30 squared here in this problem. So big B is 30 squared, which is 900. Okay, and we're going to get that out of the way here. That's my big B. And now I can finish my problem because it was all in my calculator. Now, emphasis on shape identification and connecting it with the right formula. You identify whether it's a prism, where the bases are the same on either side, or a pyramid, where there's a pointy thing, and it really is a pointy thing. You'd get the point if you sat on it, okay? When there's a pointy thing opposite the base. Here are some really quick hitters. If it is not a rectangular base, the base isn't a rectangle, but the lateral sides are rectangles in a prism. In a pyramid, the lateral edges are triangles. The lateral sides are triangles. That's straight up. You should know that. And if you're not comfortable with it, start rereading your notes. Start paying attention to what the pictures look like, because it's the same stuff that's be on the quizzes and tests you'll be taking. Now, we have cones, and I know it's ice cream weather today outside. Okay, you're thinking, oh, Rocky Roll, Fudge Ripple, these would be awesome. You know, orange sherbet, whatever your cone, you know, fixation would be. You guys can go and get the ice cream afterwards. We're just going to talk about the surface area of the cone. Okay, if you were a ice cream cone seller, you can be making them waffle cones. You know how much each waffle cone costs, so you'll mark up the price accordingly so you can cover the labor and materials to make it, along with energy, because you know it's just a waffle iron. Now, a cone is a solid that has one base and a vertex that is not in the same plane as the base. Okay, base of a cone is a circle. In the right cone, the altitude is a perpendicular segment from the vertex to the center of the base. which happens to be the center of the circle. Height h of a cone is the length of the altitude. Now we've talked about this height and altitude kind of being synonymous in these right figures. Slant height is the lazy height. It's the height that's leaning against the figure. In a cone, it doesn't matter where it's leaning. In a pyramid, it's leaning from the midpoint of a side to the vertex. Okay, but the slant height's the lazy height. It's the leaning height. Okay, and in this text, assume that cones are right cones unless otherwise stated. Now, this next slide, this is important. You see the things I have boxed in red? These guys? This is for a cone. Now, LA is equal to pi RL. SA is equal to pi RL plus pi R squared, where I define what L is and I defined what R is. Okay, if you're putting these formulas into your note sheet, you just don't put everything you see in your notes in your note sheet. You put the things that we've actually used in problems. Okay, will that cover all of them? Not necessarily, but pretty much almost most of them. Okay, but one thing about this, as you went down, if you started at LA being 1/2 perimeter times slant height, which is the general lateral area formula for something that has a base and comes to a point, and then you consider the fact that P is a perimeter, and in a circular base, perimeter is a fancy word called circumference, and circumference C becomes 2 pi r, and then 2 times 1/2 is 1. That's how we define, or the evolution of LA to become pi RL. Okay, that's all you need. You need the LA of a cone, you go pi RL. That's it. If you need SA of a cone, you've got the pi RL, which is LA, plus pi r squared, which is one base. And that's it. That's all you need. Because that's it, and that's all you need, and we're familiar with this process, go. Fill it in. Get her done. Okay, so hopefully you're looking at this formula going, well, all I need is two things. I need R, I need L. That's it. The lazy height, the slant height, which in this particular problem is 25, and the radius was the 15. So I got the original part of the problem. My pi's have to come along. My radius is 15, and over here it's 15 squared because that's the area of my base. But now I've got the slant height, which is 25. Once I make those determinations where everything goes, it's calculating time. It's order of operations. Remember order of operations, 4th, 5th grade? That's what it is once you get here. Okay, so when we got 600 pi, okay, centimeters squared. Remember, dress up your units with, you dress up your numbers with units. They get a little embarrassed. Make sure you have all the I's dotted, T's crossed. Go ahead, do 6. After you do 6, we're gonna go to 8. After you do 6, we're gonna go to 8. Yes, nice job. Remember, after we do 6, we're doing 8. 8, I want both LA and SA, and 8 is great because we have to think about Pythagorean theorem and think how we'd use that for slant height. Guys are looking good. Keep it up. Looking good. Nice. Nice job, yeah. Looking good. Remember, it's in terms of pi. It's in terms of pi, so once you get it, you're done. Nice job. Nice. Okay, looking around. Got some rock stars going on here. Love it. Got R going in. R is 16. They tell me that's 16. That's right here. That's R. Pirate's favorite thing. We got 28 is my lazy height, my slant height. Okay. 16 squared. Okay. Now, 704. Pi. Okay. Dressed up with its units. Remember, it's in terms of pi. Now, I've got the answers for 8 and 7 on top. Because at this time, everybody starts thinking, oh, I totally get this. This rocks. So I got the answers up there. Make sure you know the process to achieve them. It's not about the right answer. It's about knowing the right process, knowing the right formula you're using to get them. So get them going, and keep in mind, you got to make a right triangle to help you find slant height. Right triangle to help you find slant height. And remember, 4 is not a leg of that right triangle. You got to do something special with that value, that diameter of the circle, to get the right measurement for that triangle. What's the slant height? That's height. Think about Pythagorean theorem. Did you use the Pythagorean theorem for that? 5 will not be the slant height. That's the height. You'll use that to help you find slant height. And you'll use the value 2 to help you find slant height. Okay. Now, in 8, your start. You got that and this. And what I just did is drew a really bad right triangle, right? Okay, so pretend it's perfect. I'm looking for this L. I know that half of 4 is 2, that's my radius, and this height is 5. I'm going to use those two things with Pythagorean theorem to help me find slant height, which is the square root of 29. 4 and 25 makes 29. I got to find their square root. That's thing 1, and that's little one misstep can affect the next 3 steps in the problem, because you're using the square root of 29 for LA, and you're using the square root of 29 for SA, and because you used 2 as a radius, you're going to use 2 for the area of the base. So you have to be careful about what you're doing and know what everything's for. LA is pi RL. I just found L, the square root of 29, R is 2. So we need to know that that's the relationship we're using. It's not 4. 4 is the diameter. Okay. 33.84 feet squared. Are you doing okay? Making sense what I did? It's like tricky, right? I'm not trying to be tricky. I'm trying to make sure you recognize there are steps in this process, and there are certain requirements for us to know how to find other things. And if we're not paying attention to all the little details, we're going to miss out on something that you're very capable about doing. Now, I've got my LA's 33.84. Remember, I got it in my calculator still. SA is my LA that I just found, plus pi r squared, and remember that's the area of the base, and r is 2, so I'm squaring 2, so I'm adding 4 more pi to it, so I get 46.40 when I round to the end. Are you okay? Now, staring forward, not participating, got to get it done. Okay, this is full participation. If you've got questions, ask them. They're the same questions people have at home. Okay, now I've got my SA, my LA, and then reason why I wanted to get this one is I wanted to go LA and SA. I want you to know the difference. And now in problem 7, you're asked to just find one of them, LA, and I'm going to talk about why. When you're pouring a mixture from a beaker into a funnel to filter out the solid that is floating around in it, okay, so you can, weigh it or whatever, use something like that's akin to a coffee filter, okay? Well, if I run out of filters, I got to reorder them. And in some cases, maybe I've had filters forever. I got to reorder them, okay? This is the dimensions of the funnel I'm using, okay? Now, please be it known that I can just have them make it for me. I can slip it in. It's really great. It won't move around. But if I use one of those coffee filter things, it'll move everywhere because it's not really perfectly fitting to that funnel. So I want to make it for me. Well, what's the dimensions? I'll make the dimensions, but then I want to kind of know how much they're going to charge me. So I want to know how many square millimeters I've got here going. Again, I got to find L here because anytime I work with surface area, I'm working with the slanty height, the lazy height. Okay, so when I'm going through this, I've got to get my L. Half of 80 is 40. The height from there is 45, down to the spout area of my funnel. Okay, after that, it's calculator time. Go. Decide which one you're finding. Is it LA? It's SA. What actually is it? Because I always have people take and do more than they should just because that's what we do and don't pay attention to what they're asked. Now remember, find the lateral area, that's LA. So we got LA equals pi RL. Okay, pi is a key in my calculator. R we found to help us with our slant height, it's 40. So 40 is our R. We have slant height, and now I just plop them in, and I'm done. Okay, this is millimeters squared. Remember, a millimeter is about the thickness of a dime. Okay, so if I have 10 dimes stacked together, that's the same as a centimeter, roughly. It's a rough estimate, just so you can have a visual on what those are. Okay, and if you bend your finger, your index finger, the distance from that first knuckle to the second knuckle is roughly an inch. 12 of those should break up your foot, roughly. Okay. If you extend the span of your arms, it should be roughly your height. Okay, wingspan to height. Okay, Phelps, by the way, Michael Phelps, he's a freak. He's beyond that. His wingspan is about 3 inches longer than his height. Anyways, it's good to be a freak sometimes. 28 medals. Anyways, I'm done with notes. That's the deal. That's 11-3 day 2, and we took 27 minutes. Have yourselves a great day.